This first video is to refresh your memory on inverses and if they exist, the one-to-one property, and the horizontal line test. So this part of the lesson you do not need to take notes on, but I do need you to understand where it does come from. So the first slide here talks about an original function f of x, a linear function, and we want to find the inverse of it. So just kind of look at a picture here, get an overall feel. Remember when you're inputting a function in, what you get out, domain and range. All right, we're going to more focus on this one here. So what we have here is a linear function, y equals 5x plus 1. It's a linear function, slope-intercept form, quick graph. So what I'm going to do is I'm just going to graph it for you. Y-intercept is 1, so there's our first coordinate. And our slope is 5, so we're going to rise 5 and run 1. So we get a new point of over 1 up 6. That's going to create our line in the red. Now, earlier this year, we talked about inverse functions. How you create an inverse function is you interchange the ordered pairs. Every x becomes a y, and every y becomes an x. So what I'm going to do is I'm going to just go ahead and flip them. So this ordered pair here is 0, 1, is now 1, 0, as its inverse. The next ordered pair, 1, 6, as an inverse of it will become 6, 1. There is a reflection about the line y equals x when two lines are symmetric. About that line y equals x. Okay. Not every function has an inverse, and that's where I'm going to next. Okay? This has an inverse. The reason why this red function has an inverse is it passes the horizontal line test. It's called the one-to-one. If I give you this function here, y equals x squared, the shape of this function, you probably recognize it is a quadratic function. It's one of the parents. I'm just going to quickly graph it here. Here's the order pair 0, 0, 1, 1, 2, 4. I'm identifying a few points here on the graph. There's our parabola, our quadratic function. This quadratic function, as it exists right now, without any domain restrictions, is not one-to-one. It fails the horizontal line test. So it cannot have a function as it exists right now. But what we can do is we can restrict its domain. So I can cut it like this. And just focus on that piece of the domain from 0 to positive infinity. Now if we look at the red function, this piece here, would it pass the horizontal line test, creating it to be one-to-one? Yes, it does. So what we can then do is take those ordered pairs and interchange them. Every y becomes an x, every x becomes a y. And here's what it's going to look like. 0, 0 will still stay 0, 0. 1, 1 will still say 1, 1. But then the next point, over 2, or over 4 up 2, will look like this. Do you recognize that function? What is it? It's your squared function, right? I know none of you want to talk in this, right? So y equals the square root of x. Notice that these are inverses of each other when we have a restriction on its domain. Okay, so just to refresh your memory on these two properties, the horizontal line test and the one-to-one property. I just took these from your textbook from earlier this school year. Okay, so this part I did not want you to write down. The next part is the fun part.